Okay, we are now live.
Thank you. I see it. Thanks, Ann.
Yeah,
Good morning, everyone.
Morning.
So the minutes went out from the last meeting. I've got the agenda here now. Is there any questions with the minutes from June 6th? I have no questions myself. Get a mover and a seconder. I don't see any hands or any microphones.
Can we get a mover and a seconder so we can move on to the next item?
Also move. There's a hand from Jay. Okay. Next item on the agenda then is the Blue Block collection program. Oh, you've got the biosolids plant on the screen there right now, Catherine.
Yeah, we're just holding that there so it's ready to go when we get to that spot. But Spencer doesn't have anything to share on the screen, so that's why that's up there right now.
Okay, good. So is that yours, Catherine, or Rick?
The presentation?
Yeah.
That's Rick is going to be doing that, but right now Spencer has some updates for everybody on items 2 and 3.
Okay, so item 2, is that yours, Catherine, or
Spencer.
Good morning, Peter. I'm taking care of Blue Box update and household hazardous waste update.
Okay, thanks, Spencer.
So for Blue Box updates, for the city of Sault Ste. Marie, it's been just over a year since we have transitioned, and everything has gone smoothly so far with no major hiccups. Ontario's entering the last year now of the transition. All municipalities should be on board by the beginning of 2026. The city, we continue to be asked questions about accepted Blue Box materials. And many want to know if the list has been expanded of accepted materials. But this won't be happening until 2026 when all Ontario municipalities have transitioned. Another thing we've been working on is producing a very detailed list of public space receptacles in our community. So this would include receptacles in areas such as city parks, green spaces, municipal beaches, and transit stops. And Circular Materials has requested this information from all municipalities as they continue working towards meeting the strict recovery obligations set out by the province. So we just finished up this spreadsheet and sent it off in the past week. So now we're waiting to hear back from Circular Materials on further conversation. And that's it for Blue Box updates. For hazardous waste, we had another very successful season at our facility. There were no major regulatory changes for this season. Our crew is currently working on the last shipments of the season. We've had some trucks leave throughout the past week. Our last one will be this afternoon. We don't have any final data yet, but our annual car count and material quantities have been very comparable to previous years. It continues to be a very important service for our municipality. And just for example, the past few years, we've seen about approximately 150,000 kilograms of waste come through this facility annually. So that's all I have for hazardous waste update.
Okay, a couple of questions, Spencer. With the Blue Box program, is the city involved with that at all? Any of our trucks or any of our personnel?
Nope. Circular Materials Ontario is contracted with GFL for local collection. The only involvement that the city has is we work with Circular Materials on some promotion and education, as well as helping them with data, like as I mentioned, with the public space receptacles study.
Okay, now if the public has questions, then we should redirect them to GFL.
I would highly suggest GFL or Circular Materials Ontario. Their website has a lot of great resources on it, and they're extremely helpful to anyone that would like to reach out to them for any clarification or, any questions you may have.
Okay, with the hazardous waste collection, city staff is paid by the city then? Or is there money coming back from any other source?
We work with several different pros, producer responsibility organizations. So for different products, we would receive some funding back. Each program is set out different. Electronics is set up a little bit differently than the HSP program. So we receive some funding from these programs, and then we also would be covering some of it under our tax dollars ourselves.
Okay, so when we get the annual update, those numbers will be shown, the financial costs and the revenue from it?
Yeah, when we put together the annual report for hazardous waste, there's a section that would have what we've received for funding.
Okay, thank you. Any other questions of Spencer? Okay, on to the odor control. Is that Catherine or Rick?
Yes, I can provide an update on that. So we have received a few odor complaints as of late, and we did a review just to determine if there was anything new that was attributing to that. And there was one incident where I think there was an issue with the truck at the site, and so they had to delay covering it while they dealt with that. And then the second incident that we received recently, we did a review of the biosolids trucks and found there was some instances where the truck was leaving this site without the tarp covered or arriving with it not fully extended. So we've reviewed that with the hauler to ensure that moving forward there's more attention paid to those types of issues. And then, of course, we're moving forward with completely sealed trucks as part of the biosolids plant design, which will assist in mitigating those odors in transit. We did recently present to council on the 60% design and received approval to move forward. And so that transitions to the next item on the agenda, where we've got Rick Talvidi present to give a general overview on where that design is at.
Just one question, Catherine. I noticed the city has two big white trucks which look like septic tank pump outs. I've never seen them before. Are they collecting what it was they're actually collecting? I saw them going to the dump.
I'm not sure what trucks exactly that you're speaking of. I don't know, Spencer, I know you guys have some haulers going there that may or may not have anything to do with my operation. So do you know what those white trucks would be exactly?
Yeah, so Peter, we've had a few of these trucks for a number of years now. One of them is a catch basin cleaner. And then the others are used on site for any type of hydro excavation. So we use them within wastewater and for some other projects within public works.
Okay, it's just the first time I'd ever seen them. Okay, thank you. Welcome, Rick. You're next on the agenda.
Thanks, Peter. I believe everybody on the line knows me, but Rick Talvidi with AECOM Canada Limited, and I manage the Sioux office here. My intent is to give you an update on the biosolids plant design project and just give you an update as to what the status of the project is, as well as talk a little bit about the design details associated with it. So I'll just move forward with the agenda. So I want to give you a brief history of the project, talk about sort of the design parameters that are used in the design of the project, talk about the overall project scope and design, what components will be making up that project, and then finish off with the project cost and budgeting. So in terms of history, the project dates back to to about 2008. There was a Class EA completed. It was actually finalized in 2015. That EA was done to look at the problem of disposing of biosolids in the working face of the landfill. So it was completed in 2015. In 2016, there was a project undertaken to look at the best means of delivering the project. So we looked at project delivery alternatives, ultimately decided to proceed with what's called a conventional design bid build, which means an engineering firm would design the facility, it would be put out to tender, contractors would bid on it, and then you would build it. 2018, AECOM was retained to undertake the design and provide construction services for the project. And then over the period from 2019 to 2021, we went through a vendor pre-selection process and also issued an addendum to the EA, which we'll talk about in greater detail in subsequent slides. In 2022 to 2023, the preferred vendor prepared shop drawings for the relevant equipment that will be incorporated into the facility, and AECOM undertook the 30% and 60% design of the facility based on the vendor shop drawings that were received. In 2024, we went through some cost-saving measures to better align the project with what the city has available for budget. So in terms of why the EA was first undertaken, I'm sure everybody's aware biosolids are difficult to manage within the landfill site. They have a fairly high liquid content. They're kind of a gelatin-like substance, so there's a fair bit of moisture in them. They obviously have a fair bit of odor, and in terms of workability in the landfill, they're difficult to manage. So the intent of the project was to mitigate the odors associated with the disposal right within the working face of the landfill, to also mitigate odors in transportation of the biosolids to the landfill, and to also divert the biosolids from landfill disposal. So the intent was, if we remove this from a waste and give it a beneficial use, we could potentially enhance the projected lifespan of the landfill. And it was also recognized that there was a shortage of earthen cover materials available at the landfill. So if we could process the material and create a cover out of it, we would serve the dual purpose of opening up additional landfill capacity and at the same time address the shortage of earthen cover material that we have at the landfill. So in terms of what came out of the Class EA, from a processing perspective, it was recommended that we proceed with either an alkaline stabilization process to process the biosolids, or a composting process. And the end use, as I talked about, would primarily be to mix with native material at the landfill site and then use it as landfill cover. However, it was recognized that if we had a surplus, there are other potential applications that could be used, such as land application for agricultural purposes or for forestry. Through the EA process, the landfill site was selected as the preferred location for this facility. We recognize we are already hauling the material to the landfill, so nothing would change in terms of hauling the biosolids to the landfill. It would allow us to mitigate the odor issue in terms of disposal within the working face. It would allow us to integrate the operations or the operation of the biosolids facility with the operations that are currently ongoing with the landfill. So there might be some, we could avoid some duplication of staffing and equipment potentially. There was vacant land available at the landfill for use to accommodate it. And in terms of sensitive users in adjacent to the landfill, around the landfill site, is fairly low. So in terms of the transportation of the dewatered biosolids, it was recognized that there may be an opportunity to enhance odor mitigation en route to the landfill if we had better trailers that are better sealed, and that is part and parcel of the project as well. So from there, we moved on to a vendor pre-selection process. So there are different technology vendors out there that could provide the equipment that's necessary for processing this material. So we prepared an RFP to select a preferred vendor. Ultimately, through that process, we received 2 submissions, one from SG Gore and the other from BDP Industries. And each of those vendors proposed a distinct composting methodology. So we did not receive any submissions to process the material using alkaline stabilization. So that actually turned out to be sort of a benefit for us because from there, the province went ahead and introduced the Ontario Food and Organic Waste Policy, which basically required the municipality to achieve 50% waste reduction and resource recovery of food and organic waste, which ultimately meant that the city would have to initiate a curbside source separated organics program and then process that source separated organics. So what we and the city identified is that given that we had 2 vendors that were proposing composting technology, it was believed that these 2 vendors could likely process both the biosolids and the source separated organics. And we did reach out to both of them and both confirmed that they could. So we asked both vendors to, we prepared an addendum and asked both vendors to submit a revised proposal to use their technologies for both source separated organics and for biosolids. So an addendum went out and they resubmitted based on those 2 feedstocks. We then went through a rigorous evaluation process to select a preferred vendor. We found that both of the technologies had similar technical performance, so ultimately it kind of came down to cost. SG Gore system had a lower combined life cycle cost over a 20-year operating life cycle period. So ultimately they were selected as the preferred vendor to move forward with. What they were proposing to use was 12 bunker system, 8 of which would be dedicated to biosolids processing, and 4 of the bunkers would be dedicated to source separated organics processing. And their system included Gore cover technology, in-floor aeration system, various blowers to deliver oxygen to the composting process. It included sensors in terms of temperature and oxygen sensors, controllers, computer software, and a cover handling system. So these bunkers that were proposed, the 12 bunkers, could be either placed outdoors or they could have a roof structure or a fabric covered building placed over them if there was a need for additional odor control. So moving on from there, just to talk about the Gore system in a little bit of detail. So essentially, if we look at the bottom of the slide here, we have our sewage sludge, which in our case is in and around 25% solids. Once that's received at the facility, a bulking agent has to be added to it. So there's a mixing process where the raw feedstock is mixed with a bulking agent, which is typically wood chips or some form of wood product. It could include leaf waste as well. That material is then placed in windrows, and the windrows are then covered with the Gore cover. And ultimately, if we look to the right here, this is a cross section of one of the windrows. Over the top, you can see here is the Gore cover that covers the entire windrow. At the bottom here, there are trenches that deliver air. So blowers will force air into the static pile through these trenches. There are probes, both oxygen probes and temperature probes, that monitor the temperature of the compost pile as well as how much oxygen is being delivered to it. And the Gore cover basically is there because it is waterproof yet breathable, and it helps to accelerate the composting process, and it helps to contain odors and prevents the transmission of bacteria into the air by retaining bioaerosols and particulate matter. So the Gore cover helps us in a number of ways, and it helps the composting process. And in general, that's what the process looks like. So I've got a photo here of what the individual Gore the Gore windrows will look like. So the material is placed in these concrete bunkers. You can see here down the middle, there are 2 trenches here, and those trenches have a dual purpose to them. Again, they're at the far end here. There's a blower system that forces air through these trenches and into the static pile to help with the composting process. If there's any excess moisture in the static pile, basically it will drain. These are sloped towards these drains, so that excess moisture will drain into these drains, and that moisture is collected and it's recirculated into the process because it does have microorganisms in it that can help with the composting process. So any water or leachate that is collected through this process is actually recirculated back into the process. Here you can see up here in as number 6 is the winder, the cover winder. So this is a mechanical device that is used to wind the covers off of the piles or to apply it to the piles because they're quite heavy, as you can imagine. So that is something that Gore also provides to us as part of their delivery. So this is just a slide that sort of highlights at a conceptual level what the facility will look like. At the beginning of the process, we have offices in a scale house. So those already exist at the site as part of the landfill. So again, that's part and parcel of one of the reasons of siting the facility there. We can take advantage of some of the existing infrastructure. The material will get weighed on those incoming weigh scales, so we have an accurate identification of quantity of material for mixing purposes in our recipes. This is the first component that is built. All the rest of it here is built as part of the project. So we have our receiving building where the raw feedstock, both SSO and biosolids, are tipped inside the receiving building. This is where we will be mixing it with the amendment material or wood chips. And once we have that product mixed properly, it then will be delivered to the individual windrows and covered with the Gore covers. So again, for the biosolids, what we have is a total of 8 different windrows. And in terms of the composting process, it will stay in phase 1 of the composting process for 4 weeks. That material will then get transferred to other windrows here after 4 weeks, where it will then reside with covers again for a period of 2 weeks. And then the final phase of the composting process involves another 2 weeks. So there's a total of 8 weeks to the composting process. When the composting is done, it will then be screened with the overs get returned. Those that are larger inside will get returned to the process for reuse in the process again. And material that passes through the screening will then go into a curing stage where it will be cured for a period of a couple of months prior to use as landfill cover and mixing with the native material.
A question there, Rick, please.
Sure.
How is odor control affected through this process? I can't see any kind of.
Good question, Peter. So the entire receiving building will have odor control. So basically the odorous air that's generated. So whenever we do get a truck coming in, a trailer coming in with the raw feedstock, basically they'll open the garage door, the truck will come in, the door will be closed, the material will be tipped inside, and the doors will only be opened and closed to allow vehicles to enter and exit. And all of the air in that building will be collected and sent to a biofilter here. The biofilter will treat the odorous air. We have a biofilter at the East End Sewage Treatment Plant as an example that treats the odorous air from the sewage treatment plant. So all air within the receiving building will be treated through a biofilter. In terms of the composting process itself, the odor is going to be mitigated through the use of the Gore covers.
Okay, what about the workers themselves? Will they have to use gas masks and stuff?
We don't anticipate there will be a need for gas masks per se. But again, there will be a number of air changes. I can't remember the number of air changes per hour. I think it's 4 or 6 air changes per hour that have to be undertaken within this building. So there will be constant air changes occurring within this building.
Okay, thank you.
So now talking about sort of the design parameters, first we'll talk about the biosolids. Generally, we're generating close to 9,000 wet tons of biosolids per year from the 2 sewage treatment plants. When we look at population increases over a 20-year time frame, that could grow to about slightly over 10,000 wet tons per year. We then looked at peaking factors. In other words, on a daily basis, we could see as much as twice as much as we would see on a typical day. And on a bi-monthly basis, we could see a 15% increase in the amount we receive. So in terms of the design of the facility, when we think of the bi-monthly peak, that 10,000 could grow to close to 12,000 wet tons per year. Or when we think of the daily peaking factor, we could get as many as 80 wet tons per day. So those are the parameters that were used in the design of the facility. And I won't go through this in detail, but as I mentioned, we've got 11,850 tons coming in potentially that have to be accommodated. We add the bulking material to it. It's on a 1-to-1 ratio, so we need 11,850 tons of bulking material, leading to a requirement for 23,700 tons per year of bulking and wet biosolids. And when we worked with Gore on the design of their bunkers, ultimately we have quite a bit or a fair bit of reserve capacity there because the facility is ultimately going to be able to accommodate about 30,000 or close to 30,000 tons of materials. And with those 30,000 tons, they'll be accommodated, as we talked about, in 8 bunkers. Each of the bunkers will be 50 meters long. They'll be 7.8 meters wide, have a maximum height of 3.7 meters. So there's, like I say, 8 bunkers, 50 meters each, and that'll accommodate close to 30,000 tons per year. And then if we go to the SSO, we went through various methods to approximate how much SSO we may collect from residents as curbside. Ultimately, through various methodologies, we came up with a recommendation to accommodate 4,000 wet tons of SSO per year, and then to accommodate some non-residential organic material, we decided to increase that by 25%. So the ultimate design capacity of the facility was intended to be 5,000 wet tons per year. With a daily peaking factor of 2, that means we'd have to accommodate close to between 38 and 39 wet tons of SSO per day. And if we go to the design basis again, in this case, we only need half as much bulking material. So we have 5,000 wet tons of SSO, add our bulking agent. That gives us 7,500 tons of SSO mix per year. Ultimately, the facility is being designed for 8,600. So again, we've got a factor of safety there or some reserve capacity built in. That led us to a need to have 4 bunkers, each 30 meters long, the same width as the other bunkers at 7.8 meters with a maximum height of 3.7. And again, ultimately, that allows us to accommodate close to 8,600 tons of SSO and bulking material.
Question with the bulking material.
Yep.
Are we going to have problems with supply, or is that going to be an added cost possibly?
There is going to be cost associated with it. It's a very difficult item. We have talked with various wood waste suppliers, and they can supply the material. Obviously, it's like any material or all raw feedstock, such as wood waste. It is driven by supply and demand in terms of cost. So, we've talked to them. They've basically said, look at, depending on what, other industries require in terms of if they're asking for the material as well, which we recognize there are other competing interests locally within the economy that want to use wood waste. So a number of them said they could produce the wood waste. There's not a problem with it. Obviously, the cost will be something that is driven by supply and demand. So it's hard to predict what the cost will be. We do understand what the cost would be today, but what they will be in the future, it's difficult to predict.
I see Dave McLaughlin's hands up.
Go ahead, Dave.
Hi, Rick. Can you hear me okay?
Absolutely.
Awesome. So, correct me if I'm wrong, but this process has like 3 stages of bunkers, correct?
Correct.
Okay, so to move material from one stage to the next stage, is that a manual process, like through loaders or something like that?
That's exactly correct. All of the movement of material is done through front end loaders. So once the feedstock is prepared inside the receiving building, it will be moved by loader from the receiving building out to the first set of bunkers. After 4 weeks, the material in those bunkers will move to the second set of bunkers. And then again, it'll be moved to the third set of bunkers by front end loader. And ultimately, it'll be screened using front end loaders.
Okay. So in the winter time, 4 weeks, what's going to keep that material from freezing to allow it to be moved?
So the process itself generates a lot of heat. So composting in and of itself to actually kill the pathogens. So you'll see on my screen now what we'll be talking about next is the compost criteria. But the composting process itself generates a lot of heat. So the material, what we have found in other northern climates is that typically there is adequate heat generated and there is some insulating factor from the covers as well. So that is what basically keeps it from freezing.
Okay. Has there been like a thought that like possibly with the colder temperatures that that 4 week or the 2 week periods may have to be extended just to give the microbes a better chance to actually do their job in the cooler temperatures?
We're not anticipating it to be extended for any, much length beyond that in terms of, compost. So what you'll see here too, as I've got happens to have it up on the screen, the material shall be maintained at a minimum temperature of 55 degrees C for a minimum of 72 consecutive hours. So the period that it has to actually reach 55 degrees Celsius is quite small within that 4 week period. So we are anticipating that it should be adequate. There is, as I mentioned, quite a bit of surplus capacity built in as well. So if there is a need to increase the longevity within each phase, there is the ability to do that. And then as a further fallback, one of the reasons we wanted to site this at the landfill as well is it gives us the ability to, if there was ever a problem anywhere in the process, there is the ability to landfill the biosolids again as a contingency measure. And the time of year where we see the least problems in terms of odor complaints, obviously, is typically in the winter. So if there was any need to implement the contingency and take some of that biosolids and landfill it, we could do it quite easily. And we anticipate that given that we don't really have odor complaints through the winter, it shouldn't be problematic from an odor perspective either.
Okay, perfect. Thank you, Rick.
You're welcome. Okay, so that brings us to the compost quality criteria. The Ontario government has compost quality standards. Basically, they categorize compost into different categories based on contaminants. So the best category is a AA compost. There's a category A and a category B compost. Biosolids is not permitted as a feedstock in category AA, and it's limited to 25% of the compost feedstock in category A. In our case, because we will be using equipment that will be handling both types of feedstock. So first of all, as you probably noticed from the different windrows or the separate windrows that are going to be prepared for both SSO and for biosolids. We will be composting them completely separately. However, we are anticipating that there would be cross-contamination from the use of the same equipment for both feedstocks. So although we will have very limited amounts of biosolids in our SSO compost, there will be some cross-contamination. So we will be producing a category A compost for the SSO. And then for the biosolids compost, we will be producing a category B compost. The category A compost can be used for various municipal projects from their parks group, from their cemetery group. So we are currently using the composted leaf and yard waste for city projects. We will now be able to use the composted SSO compost for city projects. The category B compost will be mixed with as we talked about, mixed with native soils from the site and used as cover material. And then there are various criteria that have to be met in terms of pathogen kill, temperature, as we talked about. We've got to be at least 77 degrees for a minimum of 72 hours, and that obviously relates to the pathogen kill. And there's requirements for foreign matter and maturity as well that we have to meet. So in terms of the overall project scope, just to revisit this initial conceptual design, again, we've got the scale house, administrative buildings, pass over the scales, go into the receiving building, tip the material, mix the material, all the odorous air gets treated through a biofilter. It then gets loaded into the first stage of the composting process, and after 4 weeks, move to the second stage. 2 weeks later, moves to the third stage. Then it will ultimately be screened and go to the final stage of curing. So to look at each of those separately, let's first look at our landfill site. So this is our landfill site. Fifth line is down here. We have the existing household hazardous waste depot here. And there's the existing, so what we're showing here is the blue line is the existing outline of the existing disposal footprint. The black line shows the proposed landfill expansion, and it will actually require that we build new administrative buildings and waste scales and a scale house in the future. This will happen quite a few years into the future, but it will be needed. So we are showing some of the new facilities here in terms of the new garage, the new administrative building, the new public drop-off area. But again, this will occur quite a few years into the future. But our new facility is planned to be to the north of the landfill footprint. And we did want to show the proposed expansion here. So one of the challenges, obviously, because of the expansion, when we bring services into the new facility, we'll have to route it around the expanded landfill area. That includes, obviously, new hydro, wastewater, and potable water servicing for the new facility. And that's where the location is on site. So as we talked about, there's certain elements or certain infrastructure elements on the existing site that we can already take advantage of. We don't have to, as part of this project, build new waste scales or a scale house. We'll be able to use the existing waste scale and scale house to provide accurate quantification of the various feedstocks that are coming in. And that will be important to know for our recipe in terms of mixing with amendment products. And then we have operator facilities already at the landfill site in terms of showers, locker rooms, and administrative offices. So this is excluded from the biosolids management facility design because it already exists. So then looking at what we do need, as we talked about, we need a receiving building with a tipping facility. So within the building, we'll be tipping the two different feedstocks, both SSO and the biosolids. They will be tipped in separate areas of a receiving building. Within that building, we have feedstock conditioning and amendments. So again, the wood waste will be mixed with both of those feedstocks, will be thoroughly mixed within the building itself. And once those mixes are produced, they will ultimately get moved out into the field, into the windrows, as we talked about. So we do have a fairly large area on site that is dedicated to amendment product processing and storage. We do want to make sure we're able to store a fair bit of the wood waste amendment product to allow for fluctuations in seasonal supplies of that type of material. So obviously, more of that material is probably available through the spring, summer, and fall months. So we want to be able to store a fair bit of that material on site to address seasonal fluctuations in availability. We have the SG Gore pre-selected equipment. As we talked about, they will be providing basically their cover systems. They'll be providing the cover unwinder and winder. They'll provide the blowers for aeration. They'll be providing the control systems and probes that will be going into the various windrows. And ultimately, they'll provide software to control the process. At the far right, you can see some of the windrow materials with the gore covers and those that are exposed to the atmosphere at another facility. Here we have a material, here's where we're processing some of the wood waste to get it ready. It's being shredded so that it's an appropriate size to mix with the raw feedstock. And this is what we are anticipating will be what the receiving building will look like. It's going to be a canopy covered, fabric covered facility. It will not be heated to any significant temperature. Basically, we're going to keep it above freezing. You can see there's no insulation associated with it. So from a cost efficiency perspective, there will not be a lot of heating, but we do want to heat the floor, and there will be probably some supplementary heating up above to keep the building above freezing so the material is not freezing inside the building. And as we talked about, the odorous air will be collected from this building and delivered to the biofilter. As that odorous air is delivered to the biofilter, it will be heated at the inlet to the biofilter. We do want the air going into the biofilter at approximately 10 degrees Celsius, because that is the temperature we'd like to see to maintain the biological community in the biofilter. So the biofilter relies on a biological community to remove odors in that air and to make sure that that community is thriving and not dying. We need to maintain the temperature within the biofilter at about 10 degrees Celsius. So this again just shows you the process. Down below is a cross section of the windrow material within the concrete bunkers. You can see down below there are concrete trenches, and within those trenches they serve the dual purpose of delivering air to the pile and also for collecting any excess moisture. That moisture is collected and recirculated into the process because it's important to keep the moisture content at a specific level for the composting process, so that material may get re-entered, or the moisture may have to re-enter the process at some point. At the end of the bunker, so this is now looking along the profile of the windrow material. The green is obviously the gore cover, and you can see there's temperature and oxygen sensors that go into the pile, and that information is relayed back to a control unit here. That control unit then dictates when the blowers will turn on to add additional air into the system. So they're highly controlled by the sensors and probes that are in the windrow material. And this here is the winder. So this is the equipment that is used to take the cover off of the static pile or to place the cover across the static pile. So here we got some pictures of the concrete bunkers and what they look like with knee walls here. Again, you can see the trenches down the middle, serving the dual purpose for introducing air into the static piles and collecting any excess moisture. And then, of course, you see the gore covers over top. So we talked about the leachate management in terms of the collection of leachate or excess moisture in those trenches. Final screening. So here down in the bottom, you see a screening process. So the material is being delivered to a screening process with a front end loader. It goes through the screening. The larger material is stockpiled here with the compost material stockpiled separately. The compost would then go through a curing process for a couple of months following the final screening. And the overs, or the larger material, actually gets stockpiled and gets reintroduced into the process. So it actually reduces what our wood waste product requirements are. So when we first start the process, obviously we'll require a large amount of wood waste, but there is a portion of the wood waste that is recovered from the process and reintroduced into the process. So in subsequent years, the amount of wood waste that we have to source becomes lower as we are able to reuse some of it as the process continues. So in terms of other requirements, we did talk about the odor control. There will be a biofilter that will be constructed to manage the odorous air from the receiving building. Obviously, we need services for the facility, including hydro, water, wastewater, stormwater, gas, and internet. And there will be a control building that will be used to house the mechanical and electrical equipment and a washroom. So in terms of project cost and budgeting, so we're currently working on the 60% design. We had produced a 60% design. With that 60%, the original 60% design, when we looked at the cost relative to what the city has available for budgeting purposes, there was a need to look at some cost-saving measures. We did go through a cost-saving program, and ultimately, we are now working on a 60% design that we are projecting will cost in the range of 43 to 56 million. And that cost is inclusive of engineering costs, as well as all of the necessary equipment that must be purchased to assist in the operations of the facility, including front-end loaders. And obviously that cost will be refined further as the design progresses and we move to the 90% design phase and the tender phase of the project. So we're currently looking to update the 60% design by the end of the year and then move towards tendering the project in 2025. And that concludes the presentation. So I am open for any questions that people may have.
Thanks, Rick, for the presentation.
Yes, thanks, Rick. Anybody have questions at this point? I have several myself. From a taxpayer's perspective, Rick, I'm floored when I see the numbers. And we don't know about provincial funding. Well, how much will it's all going to come from the taxpayer, I'm assuming. In other words, either through the federal or the provincial taxes being fed back to build it, or simply by the local taxes. Is any of this going to be covered through the, there's a capital account from the tipping fees, or is that all just dedicated to the landfill expansion?
I can speak to the funding. So the sanitary portion of the project that's attributable to the biosolids will be funded from the sanitary reserve. And the source separated organics portion is funded from the landfill monies. And there's a business and implementation plan that went to council recently that outlined the funding model. So the business plan shows a progressive changes in the tipping fees to accommodate the business plan and also make sure that we're in line with our northern comparators. And then there's also the levy portion, which contributes to funding the landfill. So there's a whole bunch of pieces that fit into it, but we were looking at a 20%, 80% split in funding based on the sanitary versus the landfill components of the capital project.
And
Okay.
Peter, just to jump in there too, the other thing that's important, because it is a good question you've raised, the other thing to keep in mind is that this in particularly related to the source separated organics, this is something that the province has mandated the municipality to do. So it's this is coming down from the province that the municipality must start collecting source separated organics curbside and must process those organics. So it is something that is being dictated at a higher level than the municipality.
As a taxpayer, I was when I saw the numbers 43 to 58 million just for the capital costs, I'm amazed that high. But then there's also the operating costs. Are there any estimates as to what operating costs might be?
Yeah, there have been estimates completed, and those estimates have been incorporated. Catherine had mentioned the business and implementation plan that's been developed for waste management, and costs have been built into that plan to accommodate the future operating costs. And I can mention, as we talked about earlier, siting the facility at the landfill allows us to potentially, share some resources with waste management to actually operate this facility, not only sharing human resources, but also sharing equipment as well, potentially. So there are some benefits in terms of cost efficiencies that are achieved by siting it at the landfill.
The other thing that I'll note as well is, we're working on the biosolids plant to look at mitigating the odors, but because the types of solutions that we were getting were all composting, we had the opportunity to also, combine the source separated organics, which Rick mentioned is provincially mandated, into the process to try to save on costs by having one process instead of two. So the timing of that worked out well in terms of trying to look at savings there as well. So we were fortunate in that the composting can accommodate both streams.
Okay, thank you. The putting on my environmental hat, the whole process is basically a natural process that nature composts naturally, and it doesn't cost us anything. To try and duplicate what nature does is going to cost us tremendously. So somewhere in the process here, we should be, from an education standpoint, getting people to reduce the amount that goes to landfill in the first place, or gets composted by simply, some of the stats are like 30% of the food that's grown is wasted. You got to look at the reduction end rather than what to do with the end products that from our consumption. So hopefully that gets publicized along the way. Yes, we're going to go this direction, but we can reduce the cost of it by simply reducing what we end up composting, and we can promote local composting or on-site composting.
Yep, that agreed, Peter. That is a good point, and that is, in the province's mandate of 50% reduction, it is a combination of methodologies of achieving that. One of which is to reduce the amount of waste going to landfill and going to the composting process for sure. So I know the province is looking at public education programs, and I'm sure that will be part and parcel of future city programs as well.
Okay. Thank you very much. Any other questions or concerns from any of the other members? Once again, I thank you, Rick. Your presentations are wonderful.
Appreciate it, Peter. Thank you.
Any other questions or concerns? If not, can we have a motion to adjourn then? See a hand coming up. Also move. Spencer's gonna, okay, Dave and Spencer. Thank you. Our next meeting, is there one tentatively scheduled? We're supposed to have one more, I think.
We'll reach out to the committee and solicit some feedback on availability in the next week or so. I'm looking at something potentially in November, if that works for the committee, and we'll have to take a look at the content to see what makes sense for that meeting.
Okay, so we'll expect a message from Ann here shortly, I guess.
Correct, yes.
Okay, thanks everybody. Take care.
Okay, thank you.
Bye-bye.